Hello everybody. I'm trying to give you a little bit of a helpful tool to use on your lab report here this weekend. Juniors, it's due at the beginning of the day on Tuesday, and seniors end of the day on Monday. Wanted to go through the two main examples of calculation and what to do with those. So these two equations, hopefully you can see them on here, are the main ones, the first that we did in this reaction. So the first question deals with using your data for this first equation, the second part of the calculation for this one. So in the first example, let's just say that my group started and I gave them 4.5 grams of this stuff here. So remind yourself, this stuff is the blue copper chloride dihydrate. So if I have 4.5 grams of that stuff here, the first part of the question asks, how much of this dried out brown stuff should I have gotten if I started off with this much of my blue dihydrate? That's what the question's asking. And there's a couple ways to do that. We'll do it one of them ways here. So if I have 4.5 grams of this thing right here, I'm going to write the whole thing down. That's my starting point. And I want to figure out grams of this stuff here. I cannot just say that there's one of these for every one of these, and so it must be the same amount. It doesn't work that way. You first have to convert it into moles. So if I'm going to convert that into moles, I need to find its molar mass. The molar mass of copper chloride dihydrate is going to come from one of the coppers, 2 chlorines, and the waters that are right here. You get a molar mass of about 170.4 grams per mole. Okay? That is, like we've done many times before, that's how we count things, by using their mass. That was a big part of our early section here in this. So, 4.5 grams, turn that into moles. The units of grams of copper chloride dihydrate cancel, and I'm left with moles of copper chloride dihydrate. Now, I want to figure out the connection between this and this right here in my balanced equation. So I'm looking at my balanced equation. And the ratio is that for every one of these that go in, if it's blank in front, it means 1. For every one of these that go in, I get one of these that come out. So if I write that here, just to remind us, that means that for every 1 mole of CuCl2 dihydrate that go in, I should get 1 mole of CuCl2 without the waters attached out. It's a 1-to-1 ratio. These numbers are coming directly off of my balanced equation. So for everybody, that should be the same ratio. The final part of the question then would be to say, how many grams is that? How many grams of this copper chloride, that is the dehydrated version, should I get? Well, I've got to go back from moles into grams. Only this time, I have to find the molar mass of just CuCl2 without the waters attached. So it will not be the same value that this one was. It's only going to be 1 copper and 2 chlorines. And so the molar mass of that should be 134.4 grams. Okay? In this particular example, if my starting amount for my group was 4.5 grams, well then I would use my calculator momentarily, and I would go through the steps. So 4.5, that's my initial amount, times 1 over 170.4. Just divide by 170.4, right? And now I'm here. I want to multiply by 1 over 1. There's nothing to punch in, it's just 1. Times 134 over 1, or times 134.4. And I get 3.55 of what's left, CuCl2. This would be an example of what we would say, given what went in, this is the blue stuff, I would expect, or the word we might use is in theory, I would get this much. Okay, 3.55 grams of copper chloride, the brown dried out stuff there at the end of the first step. That's what I would expect given the math of the equation. This is about stoichiometry, about measuring things, and this would be the expectation based on that data. You actually did this, lab, so you want to compare this to what you actually got. Okay, I don't know what this person actually did because I made up that number. If I were to take 4.5 grams, go do the lab like you did, I would get a number out. So let's just pretend that this group, this made-up value, they ran through this lab and they got 3.25 grams actually. When they measured it, they went to the scale and found it out. Then they can make a comparison between the actual and the theoretical that we call the percent yield. The percent yield is simply a way to represent how much did you actually get compared to what you expected. Similar to saying, my recipe was supposed to make 3 dozen pancakes and it only made 2 dozen. That's a comparison that we can do and put it in a numerical form. So percent yield is the actual, what did I actually get in the lab, divided by your theoretical. In this case, it would be 3.25, my pretend actual value from this imaginary lab, over this number here, 3.55 grams. Turn that into a percentage and you'd have your actual. I'll do one more video in a second. That's on the second equation. But as you look through this here, if you have questions, come find me, send me an email, or ask somebody else who has gone through that. Thank you.